So far we learned how energy is involved in a chemical reaction. Either it's gained by the system or lost by the system. But in order to do any useful chemistry, we have to measure that energy or that heat, since in our case, energy involved will be in the form of heat energy. The way we do measurements is through something called a calorimeter, and this whole science is known as the science of calorimetry. In calorimetry, we measure the heat change in a reaction with a device known as calorimeter. While the name may sound very complicated, calorimeter, it's a very simple device. It's basically a coffee cup, as you see. Although we will look at another version of this. A coffee cup calorimeter allows us to carry out a reaction inside by adding solution to it and seeing the change in the temperature as the reaction happens. And the change in the temperature allows us to know whether the reaction was endothermic or exothermic. If it was exothermic, the temperature will go up. If it's endothermic, the temperature will go down. And depending on the exact magnitude of that change in temperature, we can figure out how much heat was gained by our system or lost by the system. In this case, our system is the liquid inside and the surrounding is everything else. Now, why do we use the styrofoam cup? Because a styrofoam cup is a very good insulator. It will not cause the heat to be lost from the sides. We don't want that to happen. We instead want to measure the heat directly as the reaction happens. And so as we mix them, we are bringing our system into a reaction, and then when the reaction happens, the heat that's released will stay inside for a long period of time, but then eventually, because the styrofoam is not perfect, the temperature will start going down even if heat is released. We are measuring the temperature from the lowest to the highest point before it starts going down. So let's look at an example of this use of a coffee cup calorimeter in figuring out the change in heat. Now, in order for us to actually figure out the change in heat, we need this equation. Q here represents the heat involved, whether released or absorbed. It depends on the mass of our system times the change in the temperature, as we talked about, times something known as specific heat of the system. Specific heat is a unique value. Its unit is basically calories per gram per degree Celsius, but it's unique for every given material or object. In the case of water, the specific heat of water is 1.00 calories per gram per degree Celsius. What does that mean? It means that if you want to heat 1 gram of water, changing its temperature by 1 degree Celsius, whatever, if it's 25 degrees, if you want to change it to 26 degrees, you need to supply 1 calorie of heat. This is different for different kinds of substances. For example, metals have very low specific heats, something like 0.45 grams, 0.45 calories per gram degree Celsius. Meaning, if you want to change the heat of a metal, let's say iron, it may have a specific heat of 0.45 calories per gram degree Celsius. Don't take my word for it, by the way. I'm just coming up with that number out of my head. But if it was 0.45 calories per gram degree Celsius, that means 1 gram of iron to change its temperature by 1 degree requires 0.45 calories. Different metals have different specific heats. We cook in aluminum because aluminum has very low specific heat. The pots and pans are made up of aluminum generally, apart from the non-stick ones, because it heats up very quickly. The lower the specific heat, its temperature will rise very quickly. On the other hand, water has very high specific heat compared to that. So it takes a lot of heat before the temperature of water will rise. That's why when you are boiling water in a pot, after 30 seconds, you may still dare to put your finger inside the water, but you may not dare to put your finger on the metal pot. Why? Because the metal pot, for the same amount of heat supplied to it as the water, its temperature will rise much more faster. The delta T here stands for the final temperature minus the initial. Delta, like I said previously, always means change, and change is the final minus initial. such as delta H was the final enthalpy, which was the enthalpy of the products minus the enthalpy of the reactants. So here is a reaction. If 0.10 moles of HCl, hydrochloric acid, is mixed with 0.10 moles of potassium hydroxide in a coffee cup calorimeter, the temperature of 150 grams of the solution increases from 25 degrees Celsius to 29.4 degrees Celsius. So the temperature on the thermometer goes up. Now, if the specific heat of the solution is 1 calorie per gram degree Celsius, we are basically using the specific heat of water, because these solutions of 0.10 moles of HCl and 0.10 moles of KOH are basically very dilute and mostly made up of water. Then calculate the amount of energy evolved in the reaction. Since delta T is 29.4 degrees Celsius minus 25.0 degrees Celsius, that's 4.4 degrees Celsius. And the heat would then equal to the mass of the solution, given here 150 grams in scientific notation, times the change in the temperature 4.4 degrees Celsius, times the specific heat of our solution, which is the same as that of water. So 660 calories of heat was released when we mixed 0.10 moles of HCl with 0.10 moles of KOH, and when the total volume was 150 grams. This is how we find the heat released or absorbed. If the temperature had gone down, we know that when we are mixing them, it's an endothermic reaction and heat is being absorbed from the surroundings. And this reaction, because the heat was released, was exothermic. There is another kind of a calorimeter for more solid samples. You may have noticed those nutritional labels behind any food product, and they list how many calories per serving and so on. Well, how do they obtain that data? Basically, they take that substance and they completely combust it inside this chamber that's within the outer chamber here. And this chamber in which combustion takes place, it takes place through this electrical wire that is the source of an electrical current, which ignites the sample, burning it completely. When it burns, it releases heat, and that heat would then escape from this smaller chamber and radiate into this outer chamber where you have water, where the fan is constantly stirring the water, so the heat is spreading out, diffusing out evenly. And there is a thermometer on one side where the thermometer will record the temperature as going up or down. This is way more sophisticated than the coffee cup calorimeter and also more accurate. However, this is specifically used for solid samples, and this is known as a bomb calorimeter, and generally the reported calories are CAL, but there is this uppercase C here. The uppercase C is also called nutritional calorie, just to make things confusing. The lowercase c is 1000 calories, and those 1000 calories equals to the uppercase calorie CAL. And so the uppercase calorie CALORI is the same as 1 kilocalorie. Okay? So when you look at those nutritional labels and it says that there are 150 calories in one serving of this tablespoon of oil or something like that, well, that calorie is the nutritional calorie. Just remember that. So if 1 gram of glucose was burned in a bomb calorimeter, 1.25 times 10 to the 3 grams, that's 1250 grams of water was warmed from 24.5 degrees Celsius to 31.5 degrees Celsius. So calculate the fuel value of glucose. 1 gram of glucose, how many calories does it contain? For those of us who are counting our calories, we are learning here how those calories are counted. The temperature went up by 6.1 degrees, final minus initial, and here we are using the specific heat of water, because it's water which ultimately absorbs the heat, as 1.00 calories per gram degree Celsius. And so the total mass of the water that absorbs the heat times the change in the temperature times the specific heat gives us 7.6 times 10 to the 3 calories, which is 7.6 kilocalories. Or if this was on a nutritional label, 1 gram for this, which would be 7.6 uppercase calories. So this is how we count calories.